Good afternoon, dear colleagues and guests. Please allow me to consider open the meeting of the Dissertation Council for the defense of Taras Leonidovich Panikorovskii's thesis for the candidate of geological and mineralogical sciences on speciality 250005 mineralogy, crystallography, on the topic the crystal chemistry of vesuvianite group minerals according to the order of St. Petersburg State University from 25th of September 2019, number 9374/1, Ms. Saidra Oleg Yakhanesovich, Doctor of Geological and Mineralogical Sciences, Professor of the Department of Crystallography of St. Petersburg State University, was appointed the chairman of this thesis council. And allow me to introduce my fellow board members. Brusnitsyn Alexey Ilyich, Doctor of Geology and Mineralogy, Head of the Department of Mineralogy. Zaitsev Anatoly Nikolaevich, Doctor of Geological and Mineralogical Sciences, Professor of the Department of Mineralogy of St. Petersburg State University. Frank Kamenetska Olga Viktorovna, Doctor of Geological and Mineralogical Sciences, Professor of the Department of Crystallography of St. Petersburg State University. Belagub Yelena Vitalyevna, Doctor of Geological and Mineralogical Sciences, Associate Professor, Chief Scientific Work of the Institute of Mineralogy of Ural, Department of the Russian Academy of Science. And in the remote mode we have Thomas, PhD, Burns University, Switzerland. Thomas, can you hear us?
I hear you clear.
You hear us, yeah? Okay.
First of all, I would like to emphasize that according to the federal law from the 23rd of August 1996, number 127, Federal Law on Science and the State Scientific and Technical Policy, St. Petersburg State University has the right to independently award academic degrees. The corresponding order on the procedure for awarding academic degrees at St. Petersburg State University, on the basis of which we conduct our meeting of the Council, was issued on the 1st of September 2016, number 6821/1. In accordance with this order, the meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Dissertational Council takes part in its work, but not less than 4 people. There are 6 members of the Council, all of them are present, including 1 member who is in the remote interactive mode. Audio and visual contact is provided with him. Thus, we have got a quorum. The procedure of today's meeting of the Dissertation Board, with a total duration of no more than 2 hours, is the following. The Chairman's summary report on the main content of the documents submitted by the candidate and their compliance with the established requirements, answers to possible questions. Brief report of the candidate for the degree reflecting the main points of his research, 20 minutes. Questions to the candidate strictly according to his report, no more than 2 minutes for one question. Responses of the candidate. The speeches of all the members of the Thesis Council by turns, with the reviews, with the statement of their positions, with questions and suggestions to the candidate, no more than 10 minutes for the speaker. The speech of the chairman with his review. The answers of the candidate for the degree, for the questions and remarks of the members of the Dissertation Council, no more than 15 minutes. Open discussion. Speeches at the request of those present at the defense of the thesis. At the same time, all interested persons are requested to register in the registration sheet and before submitting their speech fully introduce themselves for the video recording. Final answers of the applicant to the questions asked. The speech of the scientific supervisor according to the standard procedure, a 5-minute break before an open vote in order to make a conclusion on the issue of awarding or not awarding the academic degree, an open individual voting, counting of votes by the chairman of the Dissertation Council with entering the results in the minutes of the meeting, decision on awarding or not awarding the academic degree, and the final words of the applicant, no more than 2 minutes, before switching to the realization of the meeting's rules of the procedure. I remind you to switch off your mobile phones. Thank you for your attention. An audio and video recording of our meeting is being conducted, as well as a live broadcast on the website of St. Petersburg State University, and simultaneous interpretation of speeches is also provided. Let me start the procedure of the meeting. The dissertation of Panikorovskii Taras Leonidovich for the degree of the candidate of mineralogy on speciality 250005 on the topic the crystal chemistry of vesuvianite group of minerals was accepted by the scientific secretary of St. Petersburg State University. The thesis council was approved on the 25th of September 2019, number 9374/1, and I have already introduced my fellow board members to you. Our candidate submitted the following documents to the scientific secretary: an application form addressed to the rector of St. Petersburg State University, the review of the scientific supervisor Krivovich, head of the department of the crystallography of St. Petersburg State University, the corresponding member of the Russian Academy of Sciences, a list of publications containing 12 works outlining the main scientific results of the thesis, including those in peer-reviewed journals from the list approved by the Ministry of Education of the Russian Federation, 5 publications, indexed in the basis of Web of Science and Scopus, 7 publications, certificate about successful passing of candidate exams issued by St. Petersburg State University. The thesis is submitted in Russian and English as a manuscript, both in paper and based form and in the electronic form, and the thesis is designed in accordance with the requirements of National State Standards R7.0. It should be noted that all listed documents comply with paragraph 12 of section 3, presentation and defense of dissertation, procedure for awarding academic degrees at St. Petersburg State University. And now a brief report of our candidates. Distinguished board members, guests, friends, welcome to these procedures. The topic of my report is the crystal chemistry of vesuvianite group of minerals. And as for Vesuvian, it is a mesosomatic mineral which is characteristic of contact rocks and some regional metamorphic rocks, skarns and rhodongites. Into the association with Vesuvian, we take into account diapsides, garnets, epidote and calcite. Vesuvian is referred to the class of minerals with the complex type of structures. We should note that the minerals of vesuvianite group are successful indicators for the formation group. This picture, which is in the slide, is a result of work of the scientists from Switzerland, such as Brewster, and the pressure, temperature from the symmetry of the samples which were studied. And here we can clearly see the correlation between the special group and the temperature of formation. Taking into account the fact that this correlation between the symmetry and pressure can be traced, and such minerals can be crystallized in 3 various special groups, and has the formula X19, YT, Z18 or H9. The position X is occupied by huge cations, calcium, kalium of rare earth. Position Y is octaedric position in they are occupied by aluminium, magnesium and by the group of transition metals, T position. These are vacant positions, they can be occupied by boron, and these are various positions which are occupied by silicon. Tetrahedric Z positions. Crystallic structure of vesuvianite is composed by fragments of garnet structures which are polymerized according to general rocks with octahedrons filled with aluminium and have the channels which are filled with the positions of X4 and Y1 with partial occupancy because of the fact the positions are close to each other, and high symmetrical are widespread, and these positions are occupied halfly. There are different modifications of vesuvianite minerals. The more dissolved are P4 modifications with crystallized under 500-800 degrees, and ordered minerals are crystallized under the temperature 300-500 degrees, and non-centrosymmetrical, they are crystallized under low temperatures. The basis of my work is the collection of Vesuvian minerals collected from museum and private collections. The samples of Russian collectioners from Russian museums were studied, and these samples were poorly studied before. All in all, there were studied 170 samples of vesuvianite group. Such minerals have different chemical composition and symmetry. For example, the insertion of the chromium into the structure of Vesuvian produces a beautiful green color. Copper gives bluish color. Manganese gives rose color. These are photos which I studied from the collection. 60% of the samples were from museum collection. The main museum was Hersman Museum. Also, the samples from the collection of St. Petersburg State University Museum were studied, and private collections from Evgeny Vadimovich Galuskin. According to the results of the study, for those samples, we managed to define ideal type. 90% of all samples belong to mineral type of vesuvianite. About 5-6% belong to veluite, and the rest of minerals of vesuvianite group were very rare. This collection of 170 samples was characterized by two main methods: chemical composition with the help of zone techniques, and crystallic structures of all samples were studied by the methods of monocrystal diffraction with the help of X-ray structure analysis. And of high interests, the samples of high interests were different according to their chemical composition and so on. For example, Bauer's spectroscopy was used, solid state analysis, infrared spectroscopy, and so on. All in all, 13 different methods were used. According to the data of my research, there is a list of all official minerals, of vesuvianite minerals, and the most difference is in the occupancy position Y1. It is a tetragonal pyramidal coordination position, and as a result of the lowering of the symmetry of the vesuvianite group, its occupancy can vary. And the occupancy varies, the composition varies, and polyedric volume of this position can vary within the limits of 30%. Thus, we can say that the first provision is the following: the key diversity of the vesuvianite group plays the tetrapyramidal position of Y1. Ferrum dominates, fluorine Vesuvian and Hornhide, magnesio Vesuvian, willoite, alumina Vesuvian, and cyprine. Having studied the diagram between the parameters of elementary cell and the chemical composition of the samples, we can see two trends. This first trend is connected with the increase of the number of the volume of the magnesium on Vesuvianite formula, and this trend correlates with the insertion of boron into the Vesuvianite structure. Also, there is an additional trend which correlates with the increase of the magnesium volume, but this phenomenon has not been explained before. If we consider another element in the chemical composition, MVG, for example, aluminium, we can see the same trends, gradual decrease of aluminium and insertion of boron, and the second additional trend correlates with the decrease of aluminium, increase of magnesium, and this trend correlates with the increase of the number of rare earth elements, and this trend correlates to the insertion of the rare earth elements into Vesuvianite structure. We discovered new mineral, vesuvianite, in Panikorovskii massif. It is rare earth element, and it dominates in X3 position with coordination X9. The study of rare earth minerals of Vesuvianite group with the method of nuclear magnet resonance showed the presence of aluminium in the quarter coordination. It was considered impossible before, and in the doctoral degree of the chief editor Lee Andrew Groth, he wrote that aluminium could not be the part of tetrahedral positions. According to the data of solid state nuclear magnet resonance, we can see that it exists. It is shown in this slide. Also, the graph of the dependence between the polyedric volume for the positions of Y2 and Y3 for rare earth minerals of Vesuvianite group. Polyedric volume increases together with the increase of the volume of the rare earth in the structure of Vesuvian. It is accompanied with the substitution of magnesium by aluminium. Thus, we can formulate the second provision: the insertion of rare earth elements in the position of calcium X3 and X4 in the structure of Vesuvianite are compensated by the substitution of silicon by aluminium in autosilicate tetrahedrons Z10 and Z20, and it is accompanied by the increase of the volume of elementary cell. In low symmetrical varieties, vesuvianite or occurs, and depending on the extent types of this order, these schemes of ordering can be realized. Some of them correlates with tetrasymmetrical character, and when they are in one direction, they are non-centrosymmetrical type B, 4, and C. With the increased extent of ordering in the structural canals of vesuvianite, we saw the growth of additional axes which brought the rules of extinction, which broke extinction rules for a special group, and we saw which special group correlated with this or that sample of studied vesuvianite. As I have already mentioned, positions Y1 and the filling of canal positions of Y4 changed, and polyedric volume of these positions also changed. This is represented in the slide. We saw that for under different occupancy positions X4, polyedric volume of Y3A and Y3B changed. If in the layer the volume X4A was lower, the volume of Y3B was higher, and vice versa. Thus, polyedric volume of octaedros Y3AB of the skeleton of the structure is closely connected with the size of coordinational polyedros X4 and so on. According to the data of the infrared spectroscopy, we saw the area with high wave numbers, for example, and initial areas had peaks which correlated with the fluctuations in oxygen connections. And in infrared spectrum of MVG, there were changes in the absorption area. And we found out the following logic. For low symmetrical types of vesuvianite, there were peaks in a big wave area. For high symmetrical types, there were no such peaks. And this study of the position of hydrogen connections in the structure of low symmetrical vesuvianite allowed us to understand everything. The gradient of the connection change, the connection of O11, H11, O7, and high symmetrical modification of vesuvianite, this gradient was low, 100 degrees, and we can conclude that there was weak hydrogen interaction, and the increase of the role of O11, H1, O7 connection in the structure of low symmetrical samples in comparison to high symmetrical NVG leads to the increase of the intensity of absorption bands, the area of 3,590 and more. And I would like to conclude that modular character of the structure of MVG defines physical and crystal and chemical properties. The presence of Ketchian rods Y1, X4, Y1 positions with partial occupancy is the important stability factor at the which the of is realized. Another factor which is the high stability and prevalence of MVG is the presence of complex schemes of isomorphism, for example, the insertion of huge cations in position X, and it is compensated by the substitution of silicon by aluminium in different temperatures of formation of minerals of vesuvianite group from 250 to 800 degrees leads to different correlations of domains with different symmetry, and this effect influences the size of Y1AB of the positions and is the reason for the diversity of cation filling. And Y1 position, the difference in the volume of polyhedrous can reach more than 30%. Thank you for your attention. And these are my publications according to the topic of my thesis. And this is Vesuvian volcano and the samples of the minerals from those deposits. Taras, thank you very much. Distinguished board members, please ask questions according to the report. Dear Thomas, do you have any questions according to the report of our candidate?
One question would be, normally beginning students in mineralogy assume vesuvianite as a mineral of igneous rocks because of its occurrence at the volcano in the Vesuvius volcano in Italy close to Naples. Could you give us some details about the formation conditions of this vesuvianite?
Yes. Vesuvianite on Vesuvian, it is a widespread mineral, and its manifestations are connected with different volcanic eruptions. When the volcano erupts, lava, there were different metasomatic processes. For example, in particular, there are carbonate rocks, and when they interact with silicate magmas, they lead to the formation of metasomatic minerals, including vesuvianite.
Thank you.
Да?
I'm completely happy with this.
Any more questions, Thomas?
Thomas, any more questions to our candidate?
Second question would be, what about vesuvianite under very high pressure conditions? Does it exist? I mean, in the range, let's say, between 1 and 2 gigapascal.
I have some additional slides. I can show them to you if you want additional information. This is a partial answer to your question. in the works of Hallam and his co-authors on vesuvianite, which was found in ecologites, in the rocks of ecologites fraction. These pressures, maximum pressure, where vesuvianite was found 18 kilobars, it is the maximum pressure for vesuvianite.
Okay. Thank you. This was exactly I was asking for. Yes.
Thank you. Вопросы? Тогда я, наверное, дам сейчас тоже пару вопросов.
Let me ask my question. Taras, according to crystallography, you said about the centrosymmetrical and non-symmetrical vesuvianites, natural samples proved by secondary harmonics, something like that. Did you measure secondary harmonics on the samples? Hear us? Did you prove non-centrosymmetrical structures? Which methods did you use? In my work, I did not do it, but there were different measurements of physical properties. A special method was used. Their conductivity was tested. And what did you receive by these methods? When it was non-centrosymmetrical group, what can we see? Some changes when we specified in the wrong special group, we saw a large number of atoms with negative isotropic parameters of heat expansion, and we understood that the decision was wrong. We have had a few samples with correlated to non-centrosymmetrical parameters, and we paid attention to this fact. For example, when we specified the Vesuvian structure from South Urals, we did not saw the reflexes which correlated to the special group P4b. It consisted of the domains P4 and C. These are heat parameters. They were negative, and it always worked. And one more question on infrared spectroscopy. You compared the intensity of bands, and as for the side factors, the number of reflections, and can this intensity correlate with your peculiarities? Please return to this slide. I will try to show this picture. It was only the wave number changed rather than the intensity. For all the lines, we calculated the distance between two oxygens according to Leibovitsky formula, and these for low symmetrical types of vesuvianite, the larger distances existed. Bifurcation of hydrogen connection occurred, and I conduct the work on the synthetic material with my colleagues from Australia. And the last question: Apart from the nuclear magnetic resonance methods, which other methods were used? In fact, it is unchanged. That's very difficult to distinguish 25 maximum, but the increase of the connection in the tetrahedral can correlate with God isomorphism. The numbers were 3.7, but when that one position was filled by silicon, we received the numbers from 8 to 4. Say that this varied. Any more questions, Alexey Ilyich? Your question? No voice in the microphone. Mike, in your report and in the dissertation, there were three statements. The first one, that Vesuvian is the good indicator of the formation conditions. The second, Vesuvian has a high geological diversity of deposits. And the third, that it has a complex chemical composition with diverse isomorphic substitutions. And what are the typomorphic properties of Vesuvian did you find? Thank you for the question. This is habitus, beautiful multi crystal. They are of hydrothermal origin or of rhodonite origin, low temperature minerals. If we speak about high temperature vesuvianite modifications, it is a simple habitus. I meant not morphology, but the series of properties, chemical compositions, variations. In fact, chemical composition can be the same for the samples which are different from the first site. The temperature interval is very big, but for the samples, for those samples of vesuvianite which are formed under high pressure, we saw the addition of natrium. As for chemical composition, this is my answer. Or for example, chromium was not in the structure under high temperatures, only under low temperatures. Any other questions? Anatoly Nikolaevich? Can you hear me? I have some questions about chemical composition, about the diagrams which you, with the parameters of elementary cell, which you showed us, the variations in chemical composition. You mentioned that you analyzed your samples in different laboratories and with the help of different tools. In any laboratory there are own analytical conditions and standards. And if you use different standards for one element in vesuvianite, I am sure that you will receive different results. They can differ slightly, or significantly, did you try to analyze the same element in your different laboratories with the different standards? Can I start? Thank you very much for your questions. I tried. The main methods we used, when we measured chemical composition, we tested two models, and when we prepared publication, we worked in apatite also. We used microsensing. I did not see a huge difference in chemical composition. When we used Baumum dispersing device, we could observe some variables, and successful microsensing analysis helped us to see vesuvianite. Successful analytical sums in your table are represented page 276, 94, 95, 96%, but only water, fluorine were defined, and so on. I can't agree that these are successful sums. Not all analyses were of high quality. And what is the reason for this low quality of your analysis? I think that a particular case should be explained. Let's discuss them later, please. Dear colleagues, Olga Viktorovna, Елена Витальевна. No, please, no voice in the microphone.
Раз. Нет, микрофончик, пожалуйста, включите, потому что нужно для трансляции.
Taras, you studied a large number of samples. Please show us the diagrams at the beginning of your presentation. Where did you find such samples? The map, museums, private collections, and I would like to see the general classification. Some different types of deposits, for example, chemical properties, and how can you comment upon this? I can answer your question. For example, for the samples scans, there was increased components of boron. For some samples, they were low. Some samples had low quantities, low volumes of fluorine, and I will try to describe it in more detail in my further articles. It is not the first remark of such a character. I understand it very well. The second question. There is a collocation. You speak about ion substitutions and the mechanism of cooperative crystallochemistry adaptation of the structure for such substitution. Can you characterize what you do understand by this phenomenon, by this process, cooperative crystallochemical adaptation? Which parameters do you mean? Specifically, in this work, I give the parameters of polyedric volume when there is a change, different occupancy of cations rods in cation rods. For example, calcium in the position of X4A, X4B, when the occupancy is poor, polyhedric volume is higher, and in when there is full occupancy, it is lower. But the change of the volume in this position is compensated at the account of the partial substitution of magnesium by aluminium in octaedrous. But when we have a complex isomorphic substitution, we have different deformations. Can you comment upon it? So what happens? Some succession may be studied different, but I found out that the most possible is the third question is connected with the definition of spatial group. You faced with a complex task. You analyzed all tetragonal and groups P, 4, and so on. These are very accurate phenomena of dissymmetrization, and you took into account two characteristics: the laws of extinctions in the structures. You received negative temperatures, and you should take into account the fact that if, for example, you received some additional reflexes, they are not necessarily connected with the reality. These are not true reflexes. They can be false reflexes. When it is difficult to choose between these two subgroups, centrosymmetrical and non-centrosymmetrical, it is better to consider the level of verification class of the structures. What were the criteria for the choice of these special group? Thank you for the question. I would like to explain to you. As for the false reflections, Italian Angel Rose at the conference in 2013 in Novosibirsk, he doubted upon this fact, and X-ray in the tube for copper anode we use numbers which are twice bigger, and technical peculiarities did not allow to get rid of additional reflexes, but modern equipment, fortunately, presents in the resource center, and that's why I used the rules of extinction, and also I studied the correlation between X sigma if the intensity of distorted reflexes were not high. It explains the poor extent of dissymmetrization, and it is beyond the X-ray structural analysis. I'm shocked. Do you know the nature of the origin of the appearance of these reflections? I don't think that the equipment plays a great role. Let's discuss it later. How many samples did you use as for non-symmetrical group? 3 samples, if I'm not mistaken, out of 170. Low symmetrical, you mean? About less than the half, 40%, something like that. Non-symmetrical, there were 3 samples. Elena Vitalyevna? Two questions. The first one, tell me please. There is a tendency the lower 3 depending on the temperature of formation. You know it is a local fact. How did you evaluate the temperature of vesuvianite formation? Apart from the data in the literary sources, it is a review article, the graph from literary sources, individual. There was an attempt to create, on the basis of diffractional data, thermometers for the samples of the vesuvianite from Panikorovskii deposit, because they were found 3 structural modification of this mineral, and vesuvianite samples were in different associations, and that's why they had different chemical composition. That's why we studied them. On the whole, there were 3 types of vesuvianite which were different from each other. This small grain vesuvianite, in the association nepheline, huge grain green vesuvianite in the association with calcite, more recent. Then it accumulated amorphic vesuvianite containing rare earth elements. The third type, calcites, enriched with minerite, which contained garnet defects. We found out some distortions for these samples. They are represented in this slide. And we tried to create the dependence. We took into account literary data. We described the temperatures of formations on certain deposits, and this graph was composed. The number of reflexes breaking the extinction rules for 7 samples of vesuvianite from Kapdor. There were evaluations of these temperatures, and these evaluations meet the temperatures which were received from magnetic geothermometer. Carbonatite temperature of formation correlates the second temperature. And what is the temperature of carbonatite formation? What is the temperature of formation? From 600 to 300 degrees, according to estimations. One more question. In your report, you mentioned boron-bearing types of vesuvianite, willoite, bearing boron, but you indicated in the thesis that boron is in triangles and tetraedrical positions, and how was it proved? Are there any proofs apart from structural specifications? These samples were studied with the help of different methods, and there were certain peaks with different number. According to literature data, they correlated with tetraedrical, either tetraedrical boron or triangle boron. On the whole, they rated. Taras, thank you very much. Are there any other questions? Do you have any questions?
I could ask one more question, please.
Please.
I'm a little bit that the rare earth-bearing vesuvianites are extremely rich in thorium, and thorium causes metamictization of the sample. So are you really sure that the substitution of rare earths is charge balanced by tetrahedral aluminum, and is this not probably a consequence of the metamictization? Because one could also interpret the charge balance of rare earths by vacancies on the calcium sites, let's say on the X3 site, for example.
Dear Thomas, excuse me, it is not a good quality translation. Can you repeat your question?
Okay.
Okay.
The rare earth-bearing vesuvianite is also very rich in thorium oxide, having about 3% thorium oxide. So the material is fairly metamict, let's say, by radioactive reaction within the mineral structure. So are you really sure what you observe is characteristic for the rare earth substitution, or is it a consequence of the metamict state of this material?
Okay. За счет чего метамиксизация? Я думаю, что
I think that both mechanisms work here, and to most extent the substitution of the aluminium to magnesium into octaedrous it is the substitution of silicon by aluminium in tetraedrous, and the last mechanism, the isomorphism with the insertion of thorium, is of low interest.
Okay, thank you. May I ask you, just for curiosity, one more question? When I did NMR spectroscopy about 20 years ago, I was told if there is too much iron in the sample, it would not work. But now I notice that you did even NMR spectroscopy on samples for which you do iron mass power spectroscopy. Does the iron not disturb the NMR spectra?
Да?
I'm not a specialist in solid state, but iron bearing samples are for the research with the help of and we samples which had up to 5% of iron.
Okay, thank you.
Да?
Thank you. Больше вопросов у нас тогда нет.
We have no questions. And the next part of our meeting, the reviews of the board members. There are no external reviews. The distinguished board members, please. Irina is taken. Don't have to read out the whole review. It is too detailed. I want to say that it is crystal and chemical work. It is a completed work, and it reflects the full diversity of chemical compositions of Vesuvian and their structures. It is a completed work. There are a lot of publications. It can be used, and it is in the basis of classification of Vesuvian group, which was published not long ago with the participation of the author of the dissertation, and it is a completed work. There are two remarks. It is a chaotic work. The text of the work is chaotic. The results which were received before the beginning, which were received by the author, they correlate to each other, but they are mixed, and it is very difficult to understand the logics of the work and the structure. Should be the rules of the structure of the theses should be taken into account. I described it in detail in my review. And the second remark, your results are connected with the specific geological conditions of the vesuvianite studied samples. There is no general table concerning the deposits from which the vesuvianite were acquired. The temperature of formation, all this information is scattered across the text of the dissertation, and geological terminology is criticized. You should understand what's the difference between skarns and rodenthites. It is connected with the fact that the skarns are formed with the connection in the connection with garnets. There are many drawbacks. I understand that the aim of the work was not to receive some geological conclusions, but please, in the future, be attentive. As for the crystallic and chemical part, I know that it has a complex structure, different asymmetry, mosaic structure. Vesuvianite can be seen optically, territorially, and there are some variants. And I'm sure that despite my remarks, I think that You deserve the degree of the candidate of geological and mineralogical sciences. Thank you very much, Елена Витальевна. Olga Viktorovna. I am not going to read out my review. There is the scientific novelty, actuality, practical significance. I would like to emphasize that crystallic and chemical results are highly interesting. Two huge results, different ions were analyzed, and of course, basis for nomenclature, modern nomenclature, we can say that it is the doctoral achievement. Before I turn to my remarks, I can say that as for the complexity and detailed study and significance of the results, the work of Taras Leonidovich Panikorovskii conforms with the requirements for the theses, and my remarks are connected with the remarks of my previous colleague, all Elena Vasilyevna has mentioned, is connected with the quality and the form of the representation. I have 8 remarks. I hope that Taras Leonidovich got acquainted with them in detail. I'll try to be as brief as possible. All the results are chaotic. There are chapters in the thesis. Chapter 1, it is literature reviews, and chapter 3, these are the main results. In chapter 3, all the data is mixed, as I have already mentioned. And when I read thesis, I tried to understand what was the beginning. It confused me, such a chaotic character of the text of your thesis. There are a lot of remarks to the methodological work. Many methods are listed. There are a lot of methods. But the tasks of different methods, X-ray, structural analysis was the main method. But why did you use this method? You did not explain. There is a very funny section, the structure of work, but it is not a structure of the work. For example, we would like to have geological characteristic of the samples. There are a lot of methods. The results are very interesting. There is a very funny moment. There is a reference. The recycling and interpretation of the data was with the help of the program, a special program. Why did you do that? What was the aim? And you did not mention that. I have a lot of questions concerning the definition of symmetry. And the candidate uses the concept which was offered in the work of the Allen as a co-author in 1992 about the domain structure of the crystals. This work is of electron and macroscopic character, and this domain state was proved in this work. And our candidate gives the idea that the reflections which then this or that special group can be connected with this or that domain state of the crystal. But the manifestation of these domain reflections, there are a lot of such domain structures. I asked the question, structure, how the structure adapts to isomorphic substitutions. He considers the question of isomorphic deformations of the structures, but he did not use this term. If you speak about the adaptation of the structure, only volume can't be considered. It is not enough. You should take into account other factors. As for the pictures, are difficult to understand because they are not explained. Also, there are drawbacks in the work. Taras progressed a lot, of course, but the work is not deprived of drawbacks. But I can say that this thesis of Taras Panikorovskii conforms with the requirements stated by the order procedure for the awarding degrees at St. Petersburg State University, and our candidate deserves the degree of the candidate of the geological sciences on speciality 25/0005, mineralogy and crystallography. Olga Viktorovna, thank you very much. Thomas?
I follow the idea of my colleagues, and I'm not going to read the whole report. I just summarize some important points. For me, it was a unique case that for an investigation of a mineral group, 156 crystal structures were done and 159 chemical analyses were supplied. So this is almost a world record I have ever seen for the definition of a known mineral group. This is unique, and I think this is an extremely important point. The second point is not only chemical analysis and X-ray structures were used, but we must say it was a multi-methodological approach using spectroscopies of the different kind, Mössbauer IR spectroscopy, and so on. In contrast to my pre-speakers, I have to say I did not find it so much chaotic, but I may be a special case because I worked many years on vesuvianite and nothing could surprise me, and for this reason it did not appear chaotic to me. I agree that the major quality of Taras is crystal chemistry. There's some weakness in, let's say, formation conditions, geological terms, and so on, but he is a specialist, and we must accept this, and I always agree with you that in the future he should look at the connection of the crystal chemistry of vesuvianite with the geological context, saying the formation conditions and so on. But I know it's not so easy to give pressure and temperature estimates for the various deposits because very often they're just not known. So I think this is an important excuse that such data are missing. In our case, in the Swiss Alps, it was extremely easy because we know the gradual pressure temperature change in the Alps, and we could immediately assign a temperature pressure point to each sample. All in all, I think it's an outstanding thesis because it produced a lot of data which can be used for the evaluation of the large group of vesuvianite minerals, and I think it's an excellent PhD thesis which should be accepted on the standards of the St. Petersburg University. Thank you.
Да. Значит, Тарас Леонидович, я должен...
Taras Leonidovich is a very involved person, and he is enthusiastic about this study of this. He is of an emotional new mineral proves many things. Of course, the organization of the thesis leaves much to be desired. They should be altered and rewrite, and I don't want to speak about it a lot. And what will be created in the near future, the nomenclature of the vesuvianite. The minerals are very complex, and the same elements can be met in different positions, and for each finite members a special formula should be created, and it will be based on the data of the structural study. And what should people do who will work with the deposits containing a large number of vesuvianite? And as for chemical composition, there should be structural data. And if you give something more for usual reader, for example, to understand everything, it would be great. And from the formal point of view, despite the remarks, the thesis of our candidate on the topic, the crystal chemistry of vesuvianite grouped minerals, conforms with the requirements stated by the order 6821.1, procedure on awarding degrees at St. Petersburg State University. Our candidate deserves the degree on speciality 25005 mineralogy crystallography. Point 11 was not violated by our candidate. Anatoly Nikolaevich, thank you very much. Alexey Ilyich. Dear colleagues, with great pleasure I got acquainted with this interesting work. I want to say that some of the remarks were mentioned by my colleagues. Please let me read out my review. This work is very interesting. It is a strong, completed work, crystallochemistry chemistry of Vesuvians. It is a work of encyclopedic character, and the structure and composition of vesuvianite were studied in detail. The big complex of modern methods was used, and 170 samples were used. All researches were conducted at high professional level, and the thesis of our candidates is completed, but nevertheless there are some remarks. Two remarks. The style of the thesis, from my point of view, it is inadequately laconic. He tried to cover a lot of material with the help of 200 pages. There are a lot of pictures and little information. It was very difficult to understand this thesis. And of course, point of view, it is right to focus on 3 or 4 examples. And I would like to advise you to, in the near future, to correct these mistakes. And it's not a monography. Your thesis is not a monography. There is a picture and then an explanation. And the second remark, the aspirant to consider the vesuvianite as a product of physical and chemical processes, and this aspiration should be supported, but in your work you did not explain everything clearly. Your work is of crystallic and chemistry character. Vesuvianite, it is a very complex mineral. It can have different isomorphic substitutions. In this condition, it is very difficult to define different physical and chemical situations. But it is my own opinion. And finally, the third remark, there is a reference to the diversity of vesuvianite deposits. The material which was represented in the work, it characterizes practically the same mineral association. It is association of silicate and carbonate, which is formed under moderate temperatures. From the point of your physical and chemical processes, it is the same thing. In biological environments, they are carbonatites, skarns, and so on. But if we take the samples, it is the same thing, or very close things. Morphism could not be traced in your analysis. If some contrast associations were studied, or some other, but these are only my remarks. It is the point of view of mineralogists, and the work is very successful. On the whole, it is written at high professional level. The thesis of Panikorovskii on the topic "The Crystal Chemistry of Vesuvianite Group Minerals" conforms with the order procedure on awarding degrees at St. Petersburg State University, and our candidate deserves the degree of the candidate of geological and mineralogical sciences. Thank you very much. And now my review, short review without any questions. All the board members mentioned about the unsuccessful structure of the thesis, but you know that there are new rules at St. Petersburg State Universities to the theses, and there are no strict rules concerning the structure of the thesis. Taras should have chosen some specific variant of the thesis structure, and that's why there are a lot of questions to the structure of the thesis. The thesis is very completed, and Taras tried to obtain 5 new mineral types from this famous mineral, and he studied a large number of vesuvianites from museums as well as collections. There are some schemes of isomorphic substitutions, detailed study, without doubt. Taras is specialist on vesuvianite group of minerals, and he knows everything about vesuvianite group, and he tried to answer the questions successfully. And these crystals have mosaic nature. In fact, the work is not of crystallographic character. We can conclude that our candidate knows everything about fluctuation, spectroscopy, and so on. I like the illustrations of the thesis. It is very easy to read. It is the thesis of Panikorovskii, Taras, Leonidovich on the topic "The crystal chemistry of vesuvianite group minerals conforms with the requirements stated by the order from the 1st of September 2016, 6821/1, procedure on awarding degrees at St. Petersburg State University and our candidate deserves the degree of the candidate of geological and mineralogical sciences on speciality 250005, mineralogy, crystallography. Point 11 was not violated by our candidate. And now the next part of our meeting. We are pressed for time. Please, Taras, your general comments. I would like to express my gratitude to the board members for the detailed study of my thesis. I agree with all the remarks. I agree with all the remarks, and I would like to explain my mistakes. For example, chapter 1. Initially, it was a review of all the data in order to avoid unnecessary repetitions, because my research repeats up to 80 or 90% literary data. I have got 170 samples. The same thing is with chemical compositions. My examples correlated to each other, and that's why I collected everything into one review. All the remarks which concerns the accuracy of the work, the style and the language, they are accepted and they will be taken into account in the future. And as for the remark, I will try to take them into account and produce the review on crystallography of Vesuvian. It will be a separate monography. Alexey Ilyich Brusnitsyn mentioned it. And I will try to correct my mistake and use logics. Ability of the like to Alexey Ilyich not long ago, Vesuvian from sympathized periodicite was described Swiss Vesuvian. It is the territory of Switzerland. There are a lot of vesuvianite deposits in the rocks of Phism and so on. As for the prevalence of Vesuvian, there are Vesuvian-bearing sienites. They are in the central part of Kachaik. The area is 530 square kilometers. As for Elena Vitalyevna review about the contact character, Vesuvian is formed in quartz silicate rods. In order to make the formation of Vesuvian possible, the source of silicon and the source of calcium should exist. These are skarns we have mentioned. Nerodingites, for example, this map represents Shishimsky mountains. They are on the border between granitogneisses and marble-lized dolomites. And I tried to be as frank as possible in my study, and I did not make conclusions where I could not do them. As for the geothermometer, there were problems. For example, the insertion of fluorine or for low temperature Vesuvianites and it can be connected with the kinetics of crystallization. Up to this moment, I did not want to make any generalizations, and I hope that in the near future some sort of general work will be made by me. Thank you. Taras, thank you very much. Any other comments from board members? Dear Thomas, would you like to comment upon? Нет?
Спасибо. Так.
And the next part of our meeting. Are there any volunteers from among non-board members? Our guests, please ask questions to our candidate. No questions? Sergey Vladimirovich, please, the floor is yours. Distinguished board members, distinguished colleagues, distinguished guests, I would like to remember something. When I found out about the topic for this thesis, I did not offer him this topic. Crystal chemistry of vesuvianite group of minerals is a very complex topic, and you know that there were a lot of researchers in this sphere. Thomas Ambruster, Lee Horter, and other specialists studied a lot in this field. And of course, I was impressed by the depth of this study. 5 new minerals were discovered by our candidate. Only imagine this painstaking process by I that a lot of specialists before conducted researches in these spheres, but they did not take into, they took no interest in aluma vesuvian, magnesia vesuvian, monavit, and many other minerals were discovered. And Hanasevich mentioned that it produces a new scheme of isomorphism in this group. What else? It is a very multi-methodological work, and as for vesuvianite group, our candidate prepared detailed nomenclature, and among the authors there are leading famous scholars, and the first author is Panikorovskii Taras Leonidovich. It is the second huge work in this sphere. The first work was the nomenclature of the minerals of levazentrite group. It is the second work. It is a very interesting and beautiful group. As for multi-methodological aspect, 20 methods were used by our candidates, but I did not advise any method apart from usual chemical and structural analysis. All other methods are the initiative of our candidate, and 2 important features of our candidate I would like to emphasize. Today, Ilya is the head of youth laboratory. He is self-assured, he is very independent, and he is independent in choosing the methods, in the search of samples, and Ilya is a very bold, brave person. Without any doubts, he tries everything, and when he uses the methods, for example, I have not heard before about solid state magnetic resonance, but Ilya, the first member of our department, used this method. Also, there were some claims for the thesis. He wrote this thesis 2 years ago. I did not read this thesis, frankly speaking, but I read the articles of our candidate. Of course, it is the illness of the growth. In order to consider the problem from the other point of view, the time is necessary. It is a time-consuming process. And I would like to underline that I'm sure that this thesis deserves the degree, and I would like to express my gratitude to all my colleagues, and I would like to wish Taras Leonidovich every success. Sergey Vladimirovich, thank you very much. Please, your general comments. Sergey Valerievich, thank you very much for the review. The work was for a long time, and a lot of people took part in it, in this process. Evgeny Antonov, Aksionov, Galina Anastasenko, Andrei Antonov, Aya Bazai, Galina Barhudarova, Елена Габелагуб, Сергей Бритвин, Ольга Бубнова, Наталья Власенко, Евгений Галускин, Ирина Галина, Майкл Дженералов, Олег Гру, Владислав Гужий, Петр Жановский, Юрий and Андрей Золотарев, Иванюк, Владимир Карпенко, Антон Мазуль, Майкл Моисеев, Дарья Спиридоновна, Галина Старова, Игорь Пеков, Наталья Платонова, Анастасия Чернятева, Никита Чуканов, Владимир Шиловских, and I express my gratitude to them. Apart from them, I would like to say thank you to the Library of St. Petersburg State University for the free access to the literary sources, and this work would not be possible without the support of the members of the Department of Crystallography and the head of the Department of Crystallography, Sergei Piochev, and my family, Olga, Sergey, Astaf, Елизавета, Panikorovskii. And now, the concluding part of our meeting, break. 5 minutes discussion by members of the Council of the issues of awarding a scientific degree. I ask you to turn off the sound during the broadcast of the meeting. Guests and colleagues who are not members of the Dissertation Council, I ask to leave the hall. I will invite you when our consultation meeting is over. Distinguished colleagues, the meeting continues. I ask you to switch on the sound of the meeting's broadcast to make sure that it is working. The conclusive minutes of the Dissertation Council's meeting are coming. And I raise the question of awarding an academic degree to an open roll call. I remind you that the decision of the Dissertation Council on the issue of awarding the degree is considered positive if more than half of it voted for, but not less than 3 members of the Dissertation Council who participated in the meeting, in accordance with paragraph 23 of the procedure for awarding academic degrees in St. Petersburg State University. Appendix number 1 to the order. Mr. Brusnitsin, your opinion. We did not have even any discussion. It is very completed work. It has a bright result, and all the remarks we have made will be taken into account by our candidate. I am for. Olga Viktorovna, I am for, and I am glad that Taras was admitted for the defense. Thomas, what is your opinion?
Excellent work. I highly support that Taras receives the PhD degree. Thank you.
Thank you. Замечательная работа. Голосую за.
Excellent work. I am for. Thus, 6 voted for. There are no who voted against. There are no abstained. Decision on awarding the academic degree of the candidate of the sciences on speciality 250005 mineralogy crystallography is accepted. The meeting is declared closed. Thank you all for participation. Taras, do you have anything to add? I would like to express my gratitude for everyone that you found time, and I invite you to the Department of Crystallography for the party at 6 o'clock. Thank you.